In this lecture, we will introduce Pandas Data Structure series. The series is the object of the Pandas library designed to represent one-dimensional data structures similar to an array but with some additional features. So it is composed of two arrays associated with each other. The main array holds the data, so it's a NumPy array type to which each element is associated with a label, which is contained within the other array called the index. So in this figure, we can see this is a series, and the value is the main part of this series. It is actually an NumPy array, and there's also an index part of the series, and each value is associated with one index. And how to declare a series? To create the series, you simply call the series constructor and pass as an argument an array containing the values to be included in it. You can write pd.series. Just note this S is capitalized. So inside the parentheses, you write an array with 4 elements. So as if we print out S, it will be like this: the index and the value. So as you can see from the output of the series, on the left there are the values in the index, which is a series of labels, and on the right are the corresponding values. And if you do not specify an index during the definition of the series, so by default, Pandas will assign numerical values increasing from 0 to as labels. Often, however, it is preferable to create a series using meaningful labels. In this case, it will be necessary during the constructor call to include the index option and assign an array of strings containing the labels. So in this statement, for the creation of a series, we add an index argument here with A, B, C, D. So if we print out S, it will be like A, B, C, D add index, and the right part is the same values as before. So if you want to individually see the two arrays that make up this series, you can call the two attributes of the series as follows: index and values. So after creation of the array S, so you can write s.values. So it will show the value part of this array. The D type is int64. And if you write s.index, it will show the index part of this array. The D type is the object. Selecting the internal elements of series, you can select the individual elements as ordinary NumPy arrays by specifying the key. So we can write s bracket 2. Here is the third value of this array. Output is value 7. And if you also can write the index name of this element, here is C. We show the same value. You can also select multiple items in a series. So for the number type, we can write 0:2 for the first two number, the value elements of this array, first two. And we can write also string type for the name of index. So here the B, C are selected. Just note that here we use double brackets, so these two elements will be selected. We can also assign values to the elements of the series. You can select and assign the values of a series by index or by label. So there we assign the second elements of this array to 0. Then we show again this one will be 0 now. And we can also use the string type to 1. So now the b is 1. And both the series object itself and its index have a name attribute, so you can assign the main part of this series name as count, and index part of this series as a name we can assign a value called alphabet. So if we print out again as in the main part is the name count, dtype index int 64, and index part will be a name called alphabet. And we can also define a series from NumPy arrays and other series. So you can define new series starting with NumPy arrays or with an existing series. For example, ARR is a NumPy array, and we can create a series, and in parentheses we assign this NumPy array. So this series will be like the 4 elements and with index from 0 to 3. We can also define series from other series. So this is S4 is a new series, but here we int parentheses we assign the old series. Then this new series has same value as this old series. Just note that we have to always keep in mind that when you create a new series from existing arrays or series, the values contained in original NumPy array or in the original series are not copied but are passed by reference. That is, so if the values of either one changes, both either the old original one or the new one changes, then the value in the other object will also be changed. So this is called passed by reference. We will show all these statements in Anaconda Spider. See the file, section 11, introducing NumPy, introducing pandas library.py. First, import the library for the pandas and the NumPy array. Then we declare a series and show. So S is created, and we can define a series with adding index name. So index will be here, ABCD now. Can show the attribute of values of the series, values, the array, show the index of this array, ABCD, dtype object. Can select in the internal elements of an array, S2, 7, S, B, the string type, and we can select multiple elements, first 2 elements of this array series, and these 2 elements of this series. We can assign values to the elements of series. So S1 is 0. We'll show this again. Now it's 0 now. And we can assign using the series index with the string type. Now the elements of B is 1 now. We can assign the name of the main part, value part of the series to count, and the index part we assign name called alphabet. Then show this series again. So index the alphabet's name, and the main value part, the series called count, dtype is int 64. And we can define a series from NumPy array. So S3 is a series, and the value is same as this NumPy array. And we can also define a series from an existing series. So we define series S4 from an existing series S. So we show S4, the same value as S. We can change, for example, S first value to 100. So S first value is 100 now, and S4 also be changed. But they are reference to the same series. For this case also, they are reference to the same series, not a copy.